Welcome to your second and last section of week 1 of online learning with math. So, this week 1, section 2 is going to be our intro to probability. Now, this first part of probability is going to probably be something that you have seen before. So, just bear with me. Next week, we're going to get into more types of probability and a little bit more complicated. So, when we're finding probability, multiple things can happen. There are times when we're rolling a dice or flipping a coin, or if we're playing cards, kind of want to talk about finding the probability of one thing happening and then a second thing happening as well. And those two things happening can be independent of each other. Those two events being independent. And that basically means that the first event does not influence the second. An example of that is rolling a die twice. The first time you roll it, there's a 1 in 6 chance of getting a 6. The second time you roll it, still the same probability. Not going to change because of the first number you got. Those are independent. That means we can also have dependent. And that means that one event influences the next. An example of that would be if we have a deck of cards. If I have a deck of cards and I draw a king and I don't put it back, now there's less cards in the deck and there's not as many kings. So that means the next card I draw is going to have a different probability. Therefore, that first and second depend on each other. Now, conversely, if we're playing with a deck of cards and I draw my first card, I look at it and I put it back, and then I draw a second one, then those are independent of each other. It'll be the same probability. Now, to find probability, we got to talk about some notation. So, the capital P stands for the probability. The capital A is just an event. And we can put a word there. We could say A stands for this or B or anything. The lowercase n stands for the number, so we're going to count how many times that it's possible. And the capital U stands for the universal set. Basically, that's the total. So anytime you want to find the probability of something, you take the number of that event happening and divide it by the total amount. So example 1, what's the probability of getting tails when you flip a coin? So now looking at notation, we can do probability of tails here. Instead of A, we wrote the word. That's our event. Now, on a coin, the total, there are two possible outcomes, tails or heads. And there's only one tails. So the probability of us getting a tails is a 1/2 chance. Or you can write the decimal or the percentage. If you write the percentage, you better include the percent sign. Don't leave it off. Example 2. If I have a 6-sided die and I want to roll a 2 or a 4. So what's the probability of that? Well, think about a 6-sided die. How many outcomes are there possible? There are 6 possible outcomes. And rolling a 2 or a 4, how many times can that happen? That's 2. 2 out of 6 times. Now, this means we have to simplify, which is 1/3. You can write that as the decimal, which is 0.333, and we know that 3 is repeating. Or you can write the percentage. Make sure to include that percent sign. Any of these answers work. The only one that does not work is the unsimplified fraction. On a test or something, you would get partial points for 2/6, but you want to get full credit. And last but not least, example 3. If we have a D20 die, which if you don't know, that means there are 20 sides to this die. Gotta go grab a D&D dice set. And I want to find the probability of us not rolling a double digit. That's what this stands for. DBL, double. So the probability of not having a double digit. Okay, so how many options are there total? It's a 20-sided die, so there's a total of 20 options that I could get when I roll this die. How many of them are not double digits? The only ones possible are 1 through 9. So there are 9 options. We cannot simplify that, so we can write the decimal or the percentage. Any of those options work. Now, so that's thinking about from one perspective. Maybe you're playing a game and you're this person who wants to win and you need a double digit. So you're thinking about the probability of this. Whereas your opponent is sitting there thinking, well, what's the probability of them getting a single digit? In which case, these two things are actually the same number. So, two different questions that actually mean the same thing.